Oxygen delivery, Part 2. Anatomy and gas laws for oxygen delivery. The oxygen level in the blood is determined by many factors. In normal, healthy individuals, the atmospheric air containing oxygen enters through the nose or mouth, passes through the back of the mouth, called the oral pharynx, and then through the voice box, called the larynx, and into the lungs by a series of progressively smaller tubes or channels located outside and inside the lungs. The terminal ends of these channels are called alveoli. This is where the oxygen in the air moves into the blood and carbon dioxide in the blood moves into the lungs. The membrane through which this exchange occurs is called the alveolar capillary membrane. The membrane separates the dry but humid air of the alveoli from the liquid environment of the blood. The membrane is very thin, about 1 to 2 microns thick. This is thinner than a very sharp edge of a razor blade. The surface area of the lung alveoli is very large. The surface area for this exchange of oxygen and carbon dioxide is estimated to be something like the area of a football field. Finally, one must understand that as the sizes of the air passages decrease, the water content in the air inside the lungs increase. This is water vapor. I think of it like humidity. The process by which these gases are exchanged is very complex and will be discussed in this overview in general terms. The oxygen moves across the alveolar membrane, separating the dry and moist air environment of the alveoli from the fluid environment of the capillaries surrounding the alveoli. Inside the capillaries is the blood containing the red blood cells, which contain the hemoglobin molecules. This was mentioned in Part 1 of the lessons on oxygen delivery. Under normal conditions, the oxygen binds with the hemoglobin and is carried by the blood flow to all areas of the body which require oxygen to drive the aerobic biochemical mechanisms needed to maintain life. This is called metabolism. Wound healing is part of metabolism. So how does oxygen get into the blood and the red blood cells for transport to the individual cells requiring oxygen to other parts of the body? Well, we just reviewed general anatomy, which channeled air carrying oxygen into the lungs. Let's review some of the gas laws which govern movement of air and how air is dissolved in liquids. Gas laws. Probably the simplest concept is air moving from areas of high pressure to areas of low pressure. This is seen in every weather report on local and national television. High pressure systems and low pressure systems exist everywhere in the atmosphere. The high pressure system moves air towards the low pressure system. This creates winds. In a living organism like a mammal, air moves from areas of high pressure outside the lungs to areas of low pressure inside the lungs during inspiration. This situation is reversed for expiration, and these ideas will be discussed in another lesson. Another concept of air pressure is the concept of atmospheric pressure and partial pressure of gases within the atmosphere. To begin, let's illustrate the idea of pressure in the atmosphere. Quite simply, the atmosphere of the Earth is composed of many elements. These are nitrogen, the most abundant at 78%, and oxygen at 21%, and lesser elements like argon, carbon dioxide, hydrogen, methane, ozone, and many other gases. These other elements individually account for approximately 1% of the gases in the atmosphere. Imagine a column of air from the ocean surface to the outer limits of the atmosphere. The total amount of pressure exerted by this column of air can be measured. It is 760 millimeters of mercury pressure and is called 1 atmosphere pressure. The chemical symbol for mercury is Hg. 71% of that total pressure at the ocean surface is due to nitrogen, and 21% of the pressure is due to oxygen. The partial pressure of nitrogen is approximately 760 millimeters of mercury pressure times 71%, which equals 540 millimeters of mercury. The partial pressure of oxygen would be approximately 760 millimeters of mercury times 21%, which equals 160 millimeters of mercury at the ocean surface. This is called Dalton's Law of partial pressures, and it can be looked up in any textbook of chemistry or physics, or one can use any of the search engines on the internet to get more details. The next concept will be solubility. This means the amount of gas that can be dissolved in a liquid. As you can imagine, the type of liquid and the type of gas and the pressure of the gas determine how much of the gas can be dissolved in the liquid. A liquid like water and a liquid like, let's say, olive oil or mineral oil will have different abilities to dissolve gases, and the gases have different abilities to dissolve in liquids. This is measured by a solubility coefficient. It is summarized by Henry's law. Increasing pressure can dissolve more gas in a liquid, and the ability is also affected by the chemical nature of the gas and the liquid. Dissolved gas equals the partial pressure of the gas times the solubility coefficient. And to add to the complexity, each gas has its own solubility coefficient. Some elements are more soluble in water and less so in motor oil. Other elements are more soluble in motor oil than in water. Fortunately for living organisms, one looks at water. So from the bigger picture point of view, living organisms in the oceans or lakes or streams require oxygen. The pressures of oxygen in the atmosphere and the solubility of oxygen in water help to determine how much oxygen is dissolved in water to support life in the water. Another way of looking at this is, the waters of the earth are oceans of dissolved oxygen supporting life below the surface. Life forms below the surface of water and life forms above the surface of water have adapted ways of extracting oxygen from water or from the atmosphere to support life. So in review, in humans, there are anatomical structures of the respiratory tract that channels atmospheric air containing oxygen and other gases to the terminal portions of the channels called the alveoli. In the alveoli, there is an exchange of gases, oxygen and carbon dioxide primarily, which are partially governed by gas laws. The concept that air moves from areas of high pressure to areas of low pressure creates winds in the atmosphere, but aids both inspiration and expiration. The laws reviewed for this lesson were Dalton's Law of partial pressures, Henry's Law of partial pressures of a gas contributing to the solubility of a gas in a liquid, and the solubility coefficients of gases in a liquid. In Part 3 of oxygen delivery, we will review in general terms the concepts of the actual oxygen moving across the alveolar membrane and into the blood, both the red blood cells hemoglobin and the solution of blood called the plasma. Thanks.